Alrighty, this is again Calculus 1, and we are doing 1.2, finding limit of a root for this right here. So now, for this problem, do I have any restrictions on the domain? Just look at the type of problem. Is there restrictions on the domain?
No.
You say no. Why?
Because there's
Yeah, it's always positive.
It's always positive?
yes. No.
It's always going positive. Okay, so is there going to be restrictions on this though? Okay, first let's look at the type of problem. Is it a radical? Yes, say yes. Okay, good. That's what we're looking for. Don't slam my door again. Okay, now, so it is a radical. What are you not allowed to have in a square root? Negative. So that's going to give you i's, right? That's going to give you I. That's imaginary. So that's a square root. Okay? What about a cube root? They can't have it, or they can? Can. They can. In a odd numbered root, you're allowed to have negatives. An even number root, a square root, a fourth root, a sixth root, you cannot have negatives because that's going to give you i's. Because if you think about it, with even numbers, two negatives always make a positive, right? Say yes.
Yes.
Thank you. Two negatives always makes a positive, but three negatives, this is like a cube root, three negatives will give you a negative, right?
Yes.
So that is allowed. So the cube root is allowed to have negatives. So on this one, there's not going to be any restriction because there is a cube right here, right? It's a cube root of that. Now, he was bringing this up that this is going to be a square, right? Yeah. So what is that going to do for any number that I plug in there? It's always going to be positive because it's going to be squaring a number, right? Yeah. Okay, so that's good. So that's important to talk about. Now, what can we do with this one right here? Just plug in 4, right? Try it. What do we get? Plug in 4. That's going to be what? 16 plus 11 is? 27. So it is the cube root of 27. And you guys should know your cube roots to that high at least. So that's going to give you what? 3, right? Now it's going to be 3. So equals 3. Because 3 to the third power is 27. Okay, 3 to the third power is 27. So again, a lot of stuff is stuff that you guys haven't had in a long time. I will take off a shoe and throw it at you. Okay. All right, find the limit of fractional power. So this one right here with the fractional power. Now, from what we were talking about the other day, okay? So in the fraction, the top number represents what? In the fraction, the top number represents what? No, not root. The top number is my power. In the fraction, the bottom number is my root. The top number in your fraction is your power. The bottom number is going to be your root. Okay? So if I were to have, this is just for the sake of, so let's say 3 to the 3 halves. Okay, so if I were to rewrite this, okay, so this is going to be the square root of 3 to the third. Okay, does that make sense? Okay, so that's what I'm talking about. So with the fractional exponent like this. So top number's power, bottom number's root, it comes out something like that. So man, sad I just recorded that too. If f is a function for which the limit as x approaches c of f of x exists, okay, what has to happen for the limit to exist? Okay, show of hands, what has to happen? What has to happen?
They have to do the same thing.
Right? Come on, hands. So, hands, right here. Left hand and right hand, because it's even referred to as left hand and right hand. Both go to the same number, right? Very good. Okay, so both left hand and right hand go to the same number. Now, and limit as, right here, the whole limit is taken to that fractional power. We could break it up. Okay, we could break it up so we could just have the fractional power of the function, and take the limit right here. So take the limit as x approaches c of the function, and then do the power for this, or after we're done, do it there.
So the power in the roots, like, is it gonna be given to us, or are we gonna have to like find that? Does that make sense? Like, is it already gonna be written into a problem?
Yeah, you'll see it as a problem. So let me, I think the next one has something. Here it is, right here. Here is a fractional power. Okay, now, before you just go ahead and answer this, I want you to, like, plug it in, rewrite it, and then do it. Here's a hint. Do the root first. So you don't have to grab your calculator. What did you say? You are no stranger to the chocolate, are you?
Not at all.
All right, let's see. So if I'm going to rewrite this, here. So we're going to end up having the limit as x approaches 8. We plug that in. So it's going to be 8 plus 1, right, to the 3 over 2, which is 9 to the 3 over 2.
So that it's square root of 9 to
Very good. So it's going to be square root of 9. So I get square root of 9 to the third power. So I want to do my root first. Square root of 9 is easy. So that's going to give me 3 to the third now, right? Square root of 9. There we go. So which gives me 27.
Oh, I accidentally put the power into the 9. Which is why I moved my calculator.
You went 9 to the third first and then try to find the square root of that?
Yeah.
Okay. So again, that's what I said. Do the root first. It saves you a whole lot of headache. Okay, because I like working with smaller numbers. I really do. I don't like, yeah. I do not want to try and find the square root of whatever 9 to the third.
729.
Yeah. Off the top of my head, I couldn't tell you what that one is. I tried that, but you know. All right, so find the limit of a polynomial. So now, if p is a polynomial, now, what's a polynomial? Wow, got quiet again.
Sounds familiar.
Sounds familiar. You heard that word before, right?
Yeah. Is it like a to the third power?
It should be what?
To the third power? It's like more than something.
A binomial has how many?
Dos.
Dos. Okay. A trinomial has. A monomial is.
Wait, one, sorry.
Okay, if you have mono, you have one disease. Okay. A monomial.
One.
Okay, thank you. One. Monomial is one term. Okay, so, okay, so, I don't think do I need to go further? Okay, quadrinomial. 4, thank you. All right, quadrinomial. All right, so, if it's a function, then right here, we just plug in c for that function, right? It's kind of what we have been doing, just plug in c. So if it is going to exist, we will have it there, right? Okay. Oh, hey, look, there's one right there. All right, so do it. right, let's see what we got for that first one. So that first one, if we plug it in for each, right? Find the limit as each one right here. So this is going to be, let's see, 36, right?
Yeah.
36 minus 3 plus 2, which is
55.
very good. All right, do the same thing with this one right here. So that's going to give me negative 7, right? So negative 7, and that's going to be minus 4 and minus 2, right? Yes. All right, so together, what do we get? Está muy fácil.
C.
C.
Oui, symbol.
All right, find the limit of a quotient. Okay, now, it's a bunch of math jargon, if it exists. Now, for those people that actually attempted that homework, you guys got to pay attention to this piece right here. The limit of the bottom cannot do what? Equal 0, because why? Undefined. Undefined. Very good. So limit of the quotient of two functions equals the quotient of their limits, provided that the limit of the denominator is not 0. Okay. Limit of an average rate of change. It's basically just slope formula. That's all it is. Slope formula. Do you remember slope formula? It's going to be y2 minus y1 over x2 minus x1. Slope formula, right? I have 2 points. Find the slope in between there. Now, these symbols right here with the triangles, these are delta. Delta means the change. Okay, the difference of those. Okay, so that's what we're going to do. Just asking for the rate of change. So it's basically the slope. Find the average rate of change of f of x, there's my f of x, from 2 to x. From 2 to x. Where's it starting at?
2.
It's starting at 2, right?
Yeah.
And it's going to. So if I were to write a point, my first point would be what?
2.
2, comma.
10, 4.
What is it?
10.
10?
Yeah.
Where do we get 10?
Just put 2 in.
We plug in 2 because this is f of x, right?
Yeah.
Okay, so we plug in 2 into here, and we get 2 and 10, right? Okay, so there's my first point. Okay. This is all stuff you guys have been doing for a long time. It's just written a different way. It's asking it in a different form. It's the same thing, same math. Okay, different application. Now, next one. So what would be my next point be? X, comma,
2.
X. X. Oh, X.
So you don't plug in 2.
because this is going to some other number, right? So we did the exact same thing as what we did with 2, right? We had 2 here, because this is the point that we started with. We started at 2, but now the next one, hey, you're going to plug in that number. X is representing some number, right? Say yes.
Yeah.
Yes.
X is representing some number, so that number is there, right? And so where do we get 10 from? You plugged in X into my function, right?
Yeah.
And that's where we got 10. Is that a knock? All right, so now that we have that set up, it says find the average rate of change there. Okay, so this is, again, now what is my y2 or my f? Okay, what is, for my previous problem it said f of b. So that's of my second point, right? Okay, let's go back to it. So that's going to be what?
X squared plus 3x minus 10.
X squared.
X squared plus 3x minus 10 over x minus 2.
Where x cannot equal 2, right? Okay, so hey, what's that thing right there? What is it? What is it? Come on, you can say it. Come on.
Polynomial.
It is a polynomial, but which polynomial is this? Trinomial, right? Now, when you see a trinomial, what's the word? There's some word that you want to say. It's an F word, and you want to say it right now. Factor. Yeah, not the one you're thinking, right? Yeah, right? Okay, so factor. Can we factor this trinomial here? It's my favorite F word right there. Do it. Okay, I know there's no one texting right now because they're factoring this. Okay, so factoring. You should be able to actually go through, factor it out. I'll give you a second. All right, you guys ready? So on the top, I should come up with a x plus 5 and x minus 2, right? All over.
Oh, hey, whoa, dude.
Now, this is what makes it easy. This is what makes it easy. So now, what am I able to do now that I have the x minus 2 on top and the x minus 2 on bottom? Cancel it. We're going to cancel out. So this right here, what we're doing is called a removable discontinuity. Removable discontinuity. So when I try to graph this, I still will have a hole where x is equal to 2, but I remove that discontinuity so now you can see where both sides are going to that. Okay? So the average rate of change from here to here is going to give me, so I just have that function for that. Okay? So that's what we're going to have for the average rate of change. Now, find the limit as x approaches 2 of the average rate of change for this from here to here. So now, as it is approaching 2, so now this is now going to be the limit as x approaches 2. And since I was able to remove that discontinuity, so my new function is going to be of x plus 5. Right? So I removed the discontinuity. I can now plug it in, right? Before, I couldn't plug in 2 because I'll end up with 0 in the denominator. So I was able to factor it out. So now my answer is going to be what? 7. There we go. Let's see. Do I have more? Yep. I got more of this. All right. So don't forget, like and subscribe, right?